Section 8.8 is on differences of squares. A difference of squares is something of the form a squared minus b squared, and it factors into a plus b times a minus b. It's called a difference of squares because a squared is a perfect square, b squared is a perfect square, and we're subtracting them. So it's going to be very helpful if you memorize this formula. A squared minus b squared equals the quantity a plus b times the quantity a minus b. A simple example of this would be something like x squared minus 9. Because x squared is actually an x and an x, that is a perfect square, and 9 is a 3 and a 3. X is going to be my a, 3 is going to be my b, so this will factor into an x plus 3 times an x minus 3. And it doesn't really matter if you put the plus 3 first or the minus 3 first. Let's take a look at a couple examples here. Number 1, 16x squared minus 9y squared. So I need to break that down into two binomials. So this is indeed a difference of squares because 16x squared factors into x plus 4 times x plus 4. It's a perfect square because it is basically the quantity x plus 4 squared. 9y is also a perfect square because that factors into 3y and 3y, because 3y times 3y is 9y squared. So 4x is going to be basically my a, 3y is going to be basically my b. So for my final answer, I'll have a 4x plus 3y times a 4x minus 3y. And that's how you factor that. No complicated steps, just recognize that it is a difference of squares, identify a and b, put them in parentheses, one with a plus, one with a minus. Now, example number 2 here, right off the bat, doesn't look like a perfect square because I actually have an x cubed and I have an x to the 1. But one thing I'm noticing is that this has a greatest common factor of 3x. Both of those terms can be divided by 3x. So if I take a 3x out of the first term, I'm left with x squared. Take a 3x out of the second term, I'm left with negative 9. So I have the quantity 3x times the quantity x squared minus 9. X squared minus 9 is a difference of squares, factoring into an x and a 3. So my final answer is going to be my 3x that was out front times an x plus 3 times an x minus 3. So you can also solve equations that involve differences of squares. And again, we're going to be using the zero product property. Now don't be scared off by this one because it has a fraction, but we have x squared minus 4 over 25. Now, each of these are perfect squares because x squared is x times x. 4 over 25 is a perfect square because 4 is a perfect square, 25 is a perfect square. This factors into 2/5 times 2/5 because 2 times 2 is 4 in the numerator, 5 times 5 is 25 in the denominator. So x is my a, 2/5 is my b, so this will factor into an x plus 2/5 times an x minus 2/5, and that equals 0. Using the zero product property, x plus 2/5 equals 0. X minus 2/5 equals 0. And subtracting a 2/5 from each side, I have x equals negative 2/5. Adding 2/5 to each side, I have x equals a positive 2/5. And the way I like to write my answer, because they're basically the same number, one's a positive and one's a negative, x is equal to the positive or negative 2/5. X equals plus or minus 2/5. So in this lesson, we took a look at differences of squares. That's basically a squared minus b squared, and the fact that they factor into an a plus b and an a minus b, and strong recommendation that you memorize this formula.